Okay, for number 3, notice that there's an x squared plus a y squared, but the leading numbers are different, so that makes this an ellipse. However, this is a tricky one because look at, there is a 0 on the left side, but the problem with an ellipse is it's typically an x squared plus y squared over an a squared over b squared is equal to 1. And there's no way for us to just get that 0 equal to 1, so we have to do something a little bit unique. So what I'm going to do here, and remember you can't complete the square unless you first have to get the x value equal to 1. So what I'm going to do is I'm going to factor out that 49. If you do 294 divide 49, you get 6. Now I'll put a plus blank. But remember, whatever I put here, which is the 9, we actually have, it's 49 times 9. So I'll just use my phone. 49 times 9 is 441. So I'm going to, since we're adding 441 on this side, now we have a number that we can deal with. All right. And then plus 9y squared. All right. Well, remember, this side for hyperbola must equal 1. So now I'm going to divide both sides by 441. All right. Well, we already know that 441 divide 49 is 9. So I can write, and we need to write this as a perfect square binomial. So x minus 3 squared. And then 49 over 441 is 9. And then look at 441 divide 9 is 49. Now you might have to re-watch that a couple of times, but all I did here was I factored out 49, which gave us -6, and then I completed the square inside the parentheses. But when I completed the square, -6, the half of -6 is -3, -3 squared is 9. When I added the 9 here, remember it's 9 times the outside number, which is 441, and I added that to both sides. Okay, so now we can draw the ellipse, and notice the 49 under y squared is larger than the 9 under the x squared, so it will be an ellipse that will be elongated vertically. So the center is at 3, 0. Again, here, let me do this kind of big right here. And then for the x, we're going to go to the left and right 3. So 1, 2, 3, and I'm going to put an arc, and then back 3, and because we go the square root of this number to tell us how far to go left and right, and the square root of this number to tell us how far to go up and down. So we're going to, from the center, we're going to go up 7 and put an arc, and then down 7. Wow, I'm drawing this really poorly. And so the center is at 3, 0. All right, and then the next one, notice we have an x squared, but a y. So what I'm going to do is I'm going to get the y by itself. So I'm going to subtract x squared. I'm going to subtract 2x, and I'm going to subtract 5, and we can do it on both sides. Okay, and now these all have a negative sign in front, so I'm going to factor out the -1. Oops, so that's a plus sign, that's a plus sign. Now remember, this negative in front will tell us that the parabola is going to be downward facing. And right here, you could go ahead and do a table. If you like to complete the square method, we could have left the 5 over here. No. Let's not go there. Okay. Well, we could if we would have set the y equal to 0. We could have done that. But now you can just use the table. And you want to find the key point. You want to find the vertex. So the x value of the vertex is you take the opposite of b, divided by 2a. So -2 divide 2 times 1. Well, -2 divided +2 is -1. Then we take the x value of the vertex and we throw it back up into here. So -1 times -1 squared plus 2 times -1. And you could just type all that in your calculator if you want. I'm not going to. -1 squared is 1. 2 times -1 is -2. So 5 subtract 2 is 3. 3 plus 1 is 4, but 4 times -1 is -4. So at -1, -4 is the vertex. And then remember, we're going to be facing downward. And then what's the invisible slope? Well, and you could just do your table of values. So we're at -1, so 2 values to the right are 0 and 1. 2 values to the left, -2, -3. I'm just going to plug in 0 and 1 because it makes it easy. If you plug in 0, you just get 5. 5 times -1 is -5. Remember, these two are the same. And when you plug 1 in there, 1 plus 2 is 3. 3 plus 5 is 8. 8 times -1 is -8. And then you would also say parabola because you have to classify. And I don't know if I did that up here, but you remember have to put hyperbola because you have to classify each of this. And then on this one, you need to remember to classify by telling that it's an ellipse. All right, that's it for this one.